Okay, hi guys. Today we are going to discuss one of the important concept regarding Python data type. That is nothing but set. Let me share my screen so that I can proceed with the explanation. Fine. Yeah. Here guys, you are already aware of list. You are already aware of tuple. Now something is there that is known as set. Set. Set is one of the very useful and very fundamental and important concept that comes under Python data type. Python. Okay. So set is nothing but the inbuilt data type of Python that contains the elements not in proper order. What do you mean by this? What do you mean by this? For example, okay, before that, let me give you some of the points regarding sets. Okay, sets are unordered. Unordered. Ordering is not going to be followed here. Elements are going to be randomly appearing. Okay. Sets are unindexed. If the elements are going to randomly appear, obviously the indexing concept will not be applicable here. Okay, unindexed. Sets are denoted by curly braces or flower brackets. Okay. And one of the very important, very important, and this is one of the very important point from interview point of view. Sets do not contain duplicates. No duplicates are going to. I should say, no duplicates. No duplicates. So suppose your interviewer is asking you a question that I have a list. I have 5 elements inside this particular list, and one element is there. The element is 2. 2 is repeated 2 times. Can I make it 1 time? Another time, you can use the concept of set. Since set does not contain any duplicates, you have to convert that particular list into set. Once you convert, what happens is duplicates are going to be removed. You would be getting unique elements. For practical example, I should like to give you. For example, you guys are appearing for one exam, okay, and the examiner has given you 10 questions. 10 questions. So all these questions are different. Do you think that after completing the first question, coming to the next question, you are going to repeat the same thing? Are you going to be awarded the marks? I don't think so. Yeah, if the teacher is so much friendly to you, then maybe the person can give you marks. But if I would be there in that place, I'm definitely not going to award you any mark. Why so? Because you have duplicated the answer. The question 2 was different. But what you did? You replicated the answer of question number 1. Okay, you replicated the answer of question number 1 coming to question number 2. That is the reason why you got negative marks. So here also no duplicates are going to be allowed. Each question should be answered separately. Okay. In the same manner, in Python, suppose you have duplicates. Okay. If you form a set, then those duplicate elements are not going to appear in that particular set. Unique elements should be appearing. We should be coming to the example, no worries at all. Fine. Suppose I'm giving you a set. Set is something like this: 2, 3, 4, 3, 5. This is a set because I have given this flower braces or curly braces, flower bracket. 2 is repeated 1 time, but 3 is repeated 2 times. Is not it? 3 is repeated 2 times. So what do you think? If I run this particular syntax, am I going to get any error? No error. Error won't be appearing, but whatever rules and regulation that is getting followed by sets, that will be governed. Okay. When you run this particular line, you would be getting the output as set S as 2, 3, 4, 5. I don't know the order. I don't know the order in which order it will be coming up, but these are the elements which are going to be the part of the set. No duplicates are going to be allowed. Got it? And one point I told you regarding set is that sets are unordered. Never knows that 3 would be coming in the second position or the first position. It may be appearing like this. It may be appearing like this. So I don't know the order of the elements to be appearing. And once one set is defined, once one set is defined or created, the order is going to be consistent. It will be unordered in the sense randomly the things should be appearing. You were thinking that it should be appearing like 2, 3, 4, 5. Maybe it may appear like this. That is why I'm saying sets are unordered. But if this is the order which is followed by Python while printing out the result, if this is the order which is going to be followed by Python, then this order is going to be consistent. Till when? Unless and until you are not modifying that particular set. Okay. If you add another element, then it may again, what I would say, change the order. But the order is going to remain consistent once the set has been created. And what should be the order? No one knows. Fine. Now there are different methods which are part of this particular set. Some of the important and most of the times people used to ask, they are union, intersection, is disjoint, difference, symmetric difference. These are widely used, and most of the time people used to ask such kind of questions. Apart of these things, you may also learn pop, you may also learn remove and discard. What are all such things? See, when you were in your school days of mathematics, you guys are already aware of these things. If everything is going to be considered, it is known as union. Unity is strength. Unity is strength in the sense combination of all the elements should be there. So while coming to union, if two sets are there, set 1 is given like 1, 2, 3, and set 2 is given like 3, 4. If you do the union S1 dot union S2, then what will happen? All the elements are going to be clubbed. So if you go and print, if you put it here, and if you are going to print your A would be like 1, 2. Do you think that 3 is going to appear 2 times? No, because we are defining set. That is the reason why 3 is going to appear only 1 time. Then, so 1, 2, 3, 4. These are the elements which are going to be the part of your set. Now, what about intersection? Intersection is all about getting the common elements from sets. Now, suppose 2 sets are given. If I want to get the intersection of these 2 sets, intersection is nothing but the common part. The previous example, set 1 was given like 1, 2, 3, and set 2 was given like 3 and 4. So if I go for the intersection, then what will happen? The common part is nothing but 3. 3 is the common element from both the sets. So if you go for S1 dot intersection S2, you would be getting the output as 3, and this 3 would be present inside the set. Okay, so this is known as intersection. See, instead of writing this particular word, you can use symbols. Coming to union, the symbol is this vertical bar. Coming to intersection, the symbol is ampersand. We also have something called disjoint. Disjoint means no common elements. If 2 sets doesn't have any common elements, then this particular criteria is going to be satisfied. We will be coming to the example, no worries. But remember, this disjoint tells us that sets should not have any common elements. But what about difference? Different tells that from one particular set, you are going to remove the elements which are part of a different set, other set. Suppose here In the same example, I should consider something like S1 dot difference S2. S1 dot difference S2. What will happen? From S1, the elements of S2 are going to be removed. From S1, the elements of S2 are going to be removed. So elements of S2 are nothing but 3. Now what will be left? You would be getting 1, 2. That's it. 3 won't be considered right now, right? Because 3 was the common element and that would remove. So it is S1 dot difference S2 means elements present in set 1 which are also present in set 2 are going to be removed. That means the intersection part, those elements are common elements are going to be removed. Okay. What if I would have gone with S2 dot difference S1? Think from S2, the elements which are also part of S1 are going to be removed. That is nothing but 3. So the output you would be getting is only 4 within the sets. There is nothing but difference. See, difference can also be written like this: S1 minus S2. If you go with this one, that's also fine. From S1, the elements of S2 are going to be removed. That's it. There is something called symmetric difference. Symmetric difference is a little bit different from the normal difference. What happens here is suppose I would be writing S1 dot symmetric underscore difference S2. Then what will happen? From both the sets, the common parts are going to be removed. This is from both the sets. Both the sets. This is from the first set. This is from the first set. The common part is removed, and this is from the both the sets. The common part is going to be removed. So here, 3 is going to be the common part. The rest of the elements are 1, 2, 4. So you would be getting the output as 1, 2, 4. 3 won't be present. 3 won't be present. So see, the elements from both the sets are considered as the final output. So here 1, 2 is there, and in the second set 4 is there. These 3 elements are going to be considered. But in the previous case, coming to difference, only the part of this set 1 was considered. Okay, whatever you are writing, whatever object you are taking, and you are utilizing the concept of difference, from that particular object, the elements are going to be showcased, not the second object or the second set. So this is about symmetric difference. What about pop? You guys are already aware of pop because in list I think I have discussed. Coming to pop means removal of elements. If it would be list, then by default the last element would be getting removed. But since we are using sets and sets are unindexed, unordered, we don't know how the elements are going to appear in the output. That is the reason why if you go for pop, then randomly any one element is going to be removed. Randomly any one of the element is going to be removed. Now, do you think that you can put any indexing position within this particular argument? No. Indexing position won't be taken. Why? Because there is no meaning of indexing in case of sets. Sets are unordered, unindexed. Okay. So if you go with pop, that's it. Randomly any of the element from that particular set is going to be removed. Then what about remove? So if you go with remove, then what will happen is, suppose I would be writing any element you want to remove, you can pass that element and that particular element is going to be removed. That's it. If I go with S1 dot remove 2, then what will happen? 2, which is a part of your S1, will be getting removed. That's it, simple. If you go with discard, S1 dot discard. Okay. 1, then what will happen? From set 1, whatever element you have written, that will be getting removed. Now you must be thinking, then what is the difference between remove and discard if both of them are doing the same job? The difference is, for example, one unknown element is there. Unknown element in the sense, the element which is not a part of your set. For example, 12. For example, if I give 12, S1 dot remove 12. Do you think that 12 is present inside this set? No, it is not present. If it is not present, this particular syntax will raise one error that is known as key error. Key error is going to be coming up. So error is going to be raised if you go with remove method. But the same thing you are passing within this discard. If you go with discard and if you simply pass 12 to be removed, here no error will be coming up. No error will be coming up. Okay. Python will simply check whether 12 is present or not. If it is not present, that's leave it. But it will not showcase any error. So the difference comes up here. Error or no error. Getting me? Okay. Let us jump to the coding part. I have some examples to showcase you so that you can have clarity of understanding. Let's see. Sets are used to store multiple items in a single variable. Sets are unindexed, unordered. Sets can be altered. Sets do not allow duplicates. This is the major point, important point. Frozen sets are unchangeable. Frozen sets are special type of sets. All the properties of sets are going to be followed even in frozen set. But one property which is not going to follow is frozen set are immutable, whereas sets are mutable. Frozen sets are immutable, whereas sets are mutable. Immutable in the sense no changes should be made. Once a frozen set has been created, you cannot change any element. You cannot remove, you cannot add, you cannot do anything. That is what immutability means. Okay. So you can put it in the chat window. What other data types of Python follows this property, immutability? Just put it in the chat window. Let's see. Okay. Now see here, if I directly jump to this particular thing, suppose this is one set, 1, 2, 3. 3 elements are present in this particular set. If I run it, it's fine. If I go and check the type of this particular set, it would be coming up as set, SCT. Now see here, how many elements are present and what is the data type of this particular thing? See, square bracket means list. This is one list. I'm converting this list to a set. So what happens? It will be getting converted to a set. See, once it gets converted to the set, see the ordering. Previously it was A, B, C, F, which got passed, but right now the order is F, A, B, C. That's why sets are unordered. And this particular ordering is going to be consistent unless and until you are not doing any modification over that set. Now, if I want to add something to that particular set, I can add because sets are mutable. You can do the modification over that set. So I'm adding T, ADD. Okay, this particular method is going to be used inside the object called normal underscore set. Now see, suppose this is my set. Just have a look over my set. This is my set. D, B, C, A are the elements. Now, if I want to add D, previously D is already present. Okay. Now again you want to add D. Will it be getting added? Do you think that it will showcase any error? Error won't be appearing, but the rules which sustains in this particular set is going to be followed. That means duplicates are not going to be allowed. Even though you are adding D, but if you go and print your normal set, only a single time this D is coming, not 2 times. So duplicates are not allowed. Now see this. This is nothing but a list given. These are the elements present and some of the elements are repeated. If I want to convert that particular list into my set, I can use it. I can use the function called set, SCT. If I do that, I can change my list to a set. Right now my set would be looking like this. Now see, set 1 is given, set 2 is also given. 1, 2, 3, 1, 9, 0. 2 sets are given. If I go with union, I already told you, union means combination, unity. So 1, 2, 3, then 1, 9, 0. What will be the output? What do you think? 1 would be coming up one time and rest of the elements should be appearing. So if I see, it is 0, 1, 2, 3, 9. 0 is also going to be considered. 0, 1, 2, 3, 9. 1 is going to appear only one time. Got it? Now, see here. LIS is nothing but the variable, that is nothing but a set. This is my set. You are converting this set to a tuple, and at the end you are converting that particular tuple to a list, and you are storing it inside intersection underscore as underscore list. You did it. If I want to print my this one list, it would be getting printed like this. Now the same example I am taking, set 1, set 2, and right now I just want to do intersection. How can you do intersection? You can use the function called intersection, but for that you need to be aware of the English spelling of intersection. You shouldn't be making any mistake. Or else you can use the symbol ampersand. If you do that, then what will happen? The common part would be coming up. One is the common part. One is the common part. One is the common element. So that would be getting printed. So one is going to be your output. You have multiple sets, set 1, 2, 3, and you want to do the union over those sets. So what will happen? All the elements are going to be clubbed. That's it. Simple. Very easy. See, the output would be looking like this. All the elements should be coming up, no duplicates allowed. Put in mind that no duplicates allowed, unindexed, unordered. That's it. That's about sets. And sets are mutable for definitely. Set 1, set 2, both are given. And if you don't want to write down the function union like this, you can obviously use the spelling. You can use the symbol. Set 1 union set 2. That means all the elements are going to become. See. No. Set 1 is there. Set 2 is there. Okay. There is a method called each subset. This is your Earth. And this is India. This one is Earth. This one is India. So India is present inside this Earth. I should say that Earth is superset. Earth is superset of India. Is not it? And I can also say that India is subset of Earth. So note the spellings. Subset, superset. The same concept is applied here. Superset means a big set. Inside that particular set, the elements of other sets are going to come. Subset means a part of a big set. Subset means a part of a big set. So here, see, set 1 is a big set and set 2 is a part of set 1. It's not it. So 3, 4, 5, 6, 7. These elements are also present in set 1. 3, 4, 5, 6, 7. It's not it. So if I run these two lines, sets are going to be defined, and right now I'm writing set 1 dot each superset set 2. You're asking Python that whether set 1 is superset of S2 set 2. Is set 1 superset of set 2? Yes, that's true. Because set 1 is the superset here. Now you would be getting the output in Boolean format. The next one is set 2 is subset of set 1. It says it's set 2 is the subset of set 1. That's also true. That's also true. Instead of writing down this English spelling, you can obviously use this symbols. Greater equals to means set 1 is set 1. See, the greater than symbol is towards set 1. So set 1 is the superset of set 2. Same output 2. Next one, set 2 is lesser equals to means set 2 is the subset of set 1. That's also. Now you are already aware of these things. This vertical bar belongs to what? Union. And this ampersand symbol belongs to what? Intersection. Now I was telling you about what difference set 1 minus set 2. From set 1, the elements of set 2 are going to be removed. Simple, very, very easy. Where is my set 1? See this set 1 and set 2. From set 1, elements of set 2 are going to be removed. So 3, 4, 5, 6, 7 are going to be removed. The rest of the elements are going to be coming up from set 1 as 1, 2, 9. If I go and run this, I would be getting 1, 2, 9. If I would have done set 2 minus set 1, if I would have done set 2 minus set 1, what would be the output? From set 2, the elements of set 1 are going to be removed. From set 2, the elements of set 1 are going to be removed. So 3, 4, 5, 6, 7, 3, 4, 5, 6, 7 were already, all the elements are part of set 1 only. So if I run it, what do you think? What would be the output? Okay. You are going to get empty set. No elements are going to be present inside it. Now see here. This one is 1, 2, 3. Set B is set A is 1, 2, 3, and set B is 3, 4, 5. These are the elements which are part of the sets. If I go with this particular symbol, this symbol belongs to symmetric difference. As I told you, what will happen? The common part would be removed and all the elements from both the sets should be coming up. If I go and print it, you guys would be getting something like this. 1, 2, 4, 5. See here, common part here, 3. Here also 3 was present. So excluding 3, all the elements are going to come up. This is what symmetric difference is. Symmetric differences. Likewise, you guys should be aware of is disjoint. Is there any common element present within this sets, set 1 and set 2? I don't think any common element is there. If no common element is there, if I go with set 1 is disjoint set 2, is disjoint means no common elements. Since no common elements are there, it will be printing true. It will be printing true. Right now it will be true. So if it is true, if the condition is satisfied, then obviously the print statement would be coming up. Fine. What about remove? Can I remove 5 from the set 1? Yes, I can remove. Simply go and put that value. It will be removing from that particular set. Now, we also have frozen set. Everything will remain same, but coming to frozen sets are immutable. That is the only property which is, differentiable. Suppose this is a tuple given. Why tuple? Because it is in parentheses. I want to convert it into a set, frozen set. So simply put frozen set. If I go and check the type, it will be frozen set. Now, if I want to remove something from that set, is it going to be removed? No. Why no? Because it is immutable. It is immutable. But if you want to remove something from a set, that's possible. Sets are mutable. But from frozen set, you cannot remove it. Similarly, you cannot add anything to a frozen set. Again, error. Fine. I was also talking about discard, remove, and pop. Just see this. Suppose R is a set. These are the elements present. See, 3 times 3 is present. 3 times 3 is present. If I run this, it won't be throwing any error. Rather, it will be simply removing those duplicates. If I go and check my R would be 2, 3, 4. 2, 3, 4. Now, if I want to remove 3, can I remove 3? Yes, I can remove. I removed it. Let me go and check my R. If I go and check my R, 2, 4 is present. Why? Because 3 got removed. 3 got removed. Now coming to discard. Suppose again I am discarding 3. So 3 is going to be removed, is it? Yes. Here also 3 is going to be removed. My output would be 2 and 4. Why? Because 3 got removed. I discarded it. Then what is the difference between discard and remove? What is the difference? Let me show you my R right now. Suppose this is my R, 2, 3, 4. Suppose I want to remove 13. Is 13 present? 13 is not present. So as I told you, remove would be throwing you an error. If that element is not present in that particular set, it will be throwing error. Now see this. Oh, that is key error. But if you would have done the same thing with discard 13, it will check whether 13 is present or not. If it is not present, then that's fine. No issues. It won't be throwing error. No errors. It will be getting executed, no errors. What about pop? Pop would be removing randomly any element. Okay, let's see. Oh, 2 got removed. Fine. Can I pass any, what I would say, any index number inside this particular argument? Suppose I should be passing 2. Or I should be passing 0. 0 in the sense, if it would be list, then we would have thought that, okay, 0 means the first element because indexing starts from 0. But is it going to happen here? Coming to sets? No, that won't happen. Why? Because sets are unindexed, unordered. That is the reason why you would be getting an error called type error. Set.pop text no arguments. Text no arguments. Fine. If you don't pass anything, then it will be removing randomly any element. Okay, fine. So these were all about sets and all. You should be knowing all these methods. Why? Because coming to interviews, people would be asking, what is the difference between union and intersection? What is frozen set? How frozen set is different from the normal set? And is it possible to remove a particular element using pop? Such kind of questions should be counted to you. For that, you should be ready. Thank you guys. Stay tuned.